Have you ever driven past one of those massive industrial plants? A refinery or a factory, and just wondered how it all works? How does something that complex and powerful not just go completely haywire? Well, there's a kind of ghost in the machine, a hidden world of systems working around the clock to keep everything in check. And today, we're going to pull back that curtain. And yeah, that's not an exaggeration. We're talking about immense pressures, ridiculously high temperatures, and materials you really don't want to mess with. So how do you keep it all from going boom? The answer is a pretty amazing system that acts like the plant's very own brain and nervous system. So here's how we're going to break it down. We'll start with how a plant even knows what's going on inside its nervous system. Then we'll look at its automatic reflexes. After that, we'll see where people, the operators, fit into the picture. And finally, we'll talk about how humans and machines work together in perfect harmony.
Okay, so the best way to think about all this is to imagine the plant as a giant living organism. Seriously, for this thing to function, it needs a way to feel, to sense what's happening on the inside. It's all about communication.
And that's where instrumentation comes in. This is a massive network of sensors and devices that are, quite literally, the plant's eyes and ears. Without them, the entire operation would be completely blind and deaf, which is a genuinely terrifying thought. These instruments are the first and most important line of defense.
So, what are these senses actually looking for? Well, just like a doctor checks your vital signs to see if you're healthy, an industrial plant has 4 core measurements that tell operators everything they need to know about its health. First up, we've got pressure. You can think of this as the stress level inside all the pipes and tanks. If that stress gets too high, things can break badly. So yeah, keeping an eye on pressure is absolutely crucial. Next is temperature. A lot of these industrial processes are basically just controlled chemical reactions, and these reactions create a lot of heat. Temperature sensors tell us, is this reaction behaving itself, or is it on the verge of running completely wild? Then there's flow. This is just measuring how fast liquids or gases are moving through the pipes. It's basically the plant's circulatory system, making sure all the ingredients get where they need to go exactly when they need to be there. And finally, we have level. This one's pretty simple. It just tells us how full a tank is. You really need to know this, because if a tank overflows, you've got a dangerous spill. And if it runs empty, you could destroy a very, very expensive pump. So there they are: pressure, temperature, flow, and level. Just remember those 4. Around the plant, you'll hear people call it PTFL for short. Together, they give you a complete picture of the plant's health in real time. Okay, so just knowing the vital signs isn't enough, right? The system also needs to be able to react instantly and automatically. It needs to have reflexes. So all that information from the sensors travels back to the control system as a signal. The easiest way to think about it is this. An analog signal is like a dimmer switch. It can show you a whole range of values, but a digital signal is just like a regular light switch. It's either on or off. Is the motor running? Yes or no. Simple as that. Now, these signals are the key ingredient for something called a control loop. And a control loop has one job and one job only: to keep one of those vital signs locked in at a perfect target value, which we call the set point. This is the secret to keeping everything stable. And here's how that reflex works. It's a constant cycle. First, it senses the current value, like the temperature. Then, it compares that value to the set point, the temperature we want. If they don't match, it acts, telling a valve to open or close just a tiny bit to fix it. Sense, compare, act. Over and over, 24/7, without ever getting tired. But reflexes alone aren't enough. You still need a brain, a consciousness to oversee the whole operation and make the big decisions. And that's where the human operator comes in. Operators have 2 basic ways to interact with these control loops. Most of the time, things run in auto mode, where the system just handles itself. But sometimes, like during a startup, the operator has to switch to manual and take direct control. And that requires their absolute undivided attention, because one wrong move can throw the whole process off balance fast. So what happens when this flashes on the screen? What happens when one of those vital signs starts to drift way off target and the automatic reflexes just can't keep up? Well, that's when the system knows it's time to call for help. And that call for help is an alarm. This is the first layer of protection. It's a flashing light, it's a loud horn, it's the system basically shouting, "Hey, human, you need to look at this right now." It's a direct request for human judgment to step in and figure out what's going on. Now, if things get even more serious, the next layer of safety kicks in, the interlock. An interlock is a hard-coded safety rule that can't be broken. For instance, it might physically prevent an operator from opening a valve if the tank pressure is already too high. It's the system saying, nope, sorry, I literally will not let you do that because it's unsafe.
And if all else fails, if the situation is truly critical, there is the trip. This is the absolute last line of defense. A trip is when the system decides things are too dangerous and it automatically slams on the brakes, shutting down equipment or even the entire unit to prevent a disaster. A trip saves equipment, and more importantly, it saves lives.
So you've got the senses, the reflexes, and these layers of automated protection. The final piece of this whole puzzle is getting the human operator and this incredibly smart machine to work together as a seamless team.
And this is how the best operators do it. They learn to watch the trends over time, not just fixate on a single number. They're constantly communicating with everyone on their team. They would never, ever bypass a safety interlock. The whole goal is to work with the control system, to use its power, not to fight against it.
And really, this quote says it all. This is the entire philosophy of modern industrial control. The automation, the technology, it isn't there to replace people. It's there to support them. It handles the boring, repetitive stuff so that the operator's brainpower and judgment can be used for what really matters. Which leaves us with a really fascinating question to think about. As these automated systems get smarter and smarter with things like AI and machine learning, what does that balance look like? Where should we draw the line between what the machine controls and where the irreplaceable value of human experience and intuition takes over? That's the big question everyone in this field is trying to answer right now.